Today we will explore the topic of organic flow batteries and build one. It all started with this German research paper I found a while ago. In addition to other organic substances, it describes a battery based on a Matcha tea carbon electrode. How cool is that? First of all, I made the carbon electrode. It's a so-called oxygen-consuming electrode. The basic design was created by chemist Marco Oetken. The idea for the breast tube housing with soldered-on threaded insert nuts to secure the carbon rod and the banana plug was my own. The plastic part shown here is a perforated sleeve from the hardware store. It is typically used as a dowel. To make it easier to fill in the activated carbon, I used a ground joint funnel. Ideally, the activated carbon particles should be larger than the holes in the sleeve. The activated carbon particles should completely surround the carbon rod. The activated carbon ensures that the electrode has a very large surface area. Some people have asked me how I got into chemistry. Well, when I was about 8 years old, I set up my first little chemistry lab in the basement of our house with the help of my father, who was a chemist. Back then you could still buy potassium nitrate at the pharmacy, and the pharmacist would ask you with a smile if you also needed sulfur and carbon powder. Okay, back to the topic. Next, I worked on the display panel. I designed it in Inkscape and had it cut from 3mm thick sheet of acrylic. I also picked up some analog voltmeters and ammeters. And this is what the panel looks like once it's assembled and wired up. By the way, I had to use a smaller propeller because a larger one interfered with the banana plugs. For the frame I once again opted for the tried and true 2020 aluminum extrusion with the appropriate accessories. I also cut a 4mm aluminum blade to size and screwed it to the bottom of the frame. The aluminum blade serves as a base for a small magnetic steerer. Next, I attached the panel to the frame and added two arms equipped with pipe clamps and cable grommets which serve as electrode holders. Speaking of electrodes, the next step in building the battery was to make two platinum electrodes. The platinum electrodes were inserted into the PVC tubes and then encapsulated in epoxy resin. To do this, I filled the resin into a disposable syringe fitted with a dosing needle. This allows the resin to be degassed by creating a vacuum. I also made the banana plug cables needed for the experiment myself. To do this, I crimped a ferrule onto a silicone-coated cable and then attached it to the banana plug with the internal set screw. This creates a highly durable connection that won't come loose. Okay, one more electrode to make before the final assembly of the battery. It is made of 0.2mm graphite foil. I use a ceramic cylinder designed specifically for electrochemical cells. However, you can also use a terracotta flower pot. Since there isn't much room for the platinum electrode, I attached a piece of aluminum tubing directly to the pipe clamp using epoxy adhesive to serve as a mount. I did the initial wiring off camera again. Please note there is still one electrode missing, but rather than confuse you even more, I will show you just the complete setup as a diagram. Since the carbon electrode is an oxygen-consuming type, adding sodium peroxide disulfate is not actually necessary. However, because it decomposes into oxygen, hydrogen peroxide and sodium sulfate in aqueous solution, the electrode's efficiency is significantly increased. Now for the interesting part, matcha tea. It contains a substance that is relevant to our experiment. The substance has an unpronounceable name, so I leave the job to the AI.
Epigallocatechin gallate.
Fortunately, you can also refer to it as EGCG. EGCG is the most abundant catechin in tea. It is a polyphenol currently being studied for its potential impact on human health and disease. A suspension was then prepared using the sodium hydroxide solution and the matcha tea. The silver chloride electrodes, the platinum electrodes and the potassium chloride solution are used solely to measure the battery's electrode potentials. You can also omit them entirely. When filling the ceramic cylinder with sulfuric acid, care must be taken to ensure that the carbon electrode is not completely submerged. Finally, the sodium hydroxide matcha tea suspension was added. At that very moment, the battery started working. I couldn't read the reference voltages with the analog voltmeter, so I connected a multimeter. The research paper proposes the following reaction mechanism. Unlike in the research paper, I didn't take continuous measurements and plot a graph. Nevertheless, I'd like to show you the results from the research paper.
8 hours later.
Yeah, the motor was still running, but unfortunately, that's all the time I have for you today. Stay true, stay you.